Good afternoon, students. So last year we have discussed about the matter and composition, matter and its composition. Now today we will continue with that chapter also. Now last year we have discussed what is solid and what is liquid and what is gases. That means I have told you that matter can exist in three states: solid, liquid, and gas. And already I have told you that what are the examples of matters, that means solid, liquid, and gases. Now we have to know that how matter is composed. Normally every matter or every element is built by small kinds of particles. Every element built by small kinds of particles. Those particles are called atoms. So every element consists of small number of atoms. Those particles are similar to each other for every element. Say I am telling that for oxygen is an element. Its symbol is O. Now oxygen element will contain large number of oxygen atoms, and when you join together those large number of oxygen atoms, you will get the oxygen element. Okay. Now normally, and every oxygen atoms will have the same chemical and physical properties, but normally we cannot create the atoms. Atoms are individual particles and we cannot create or destroy the atoms. Okay, so atoms are indivisible particles. Atoms are indivisible particles of elements which cannot be created or destroyed. Okay, and atoms of similar element will have similar chemical and physical properties. Okay, now again one thing we have to learn, that atoms are not independent. Okay, they are not stable in nature. Atoms are not independent. Normally in oxygen atom, it cannot be present as independent because it is not stable. So what will happen? One oxygen atom will always try to connect with another oxygen atom. Okay, one oxygen atom will always try to connect with another oxygen atom to form oxygen molecule. O2. So any atom will always try to join with another atom to form molecule. Okay, and to get the stability. So normally atoms are not stable, and when it will form the molecule by joining with another atom, it will be stable. So by this description we can say that atoms are not stable but molecules are stable. Atoms are not stable but the molecules are stable. So these are the normal description of atoms and molecules. Now we can write the difference between atom and molecule. Atom and molecule. Okay, just try as your HW in your home. Okay, so you can write this one, difference between atom or molecule. If you cannot write, I will send you by WhatsApp. Okay, so try this one. Now we will discuss about the interatomic attraction forces and interatomic or intermolecular space between the different states of matter. Now I have already discussed last day that we have three states of matter. One is solid, number two is liquid, and number three is gas. Every matter can exist in these three states, and these three are called solids, liquid, and gas. Normally you know water can be present normally is in liquid state, but when we heat that water, it will vaporize. So that state will be gaseous state. But again, when you take the water and take into the refrigerator, then it will be solidified and it will form a ice. So normally a particular matter can exist in different kinds of states. This one we have already discussed. Now we will discuss about the intermolecular space and intermolecular attraction force. Now normally solid, you know, I have taken this chalk. This one is solid. Now the size of this solid, a particular size you get, and it will get a particular volume. Okay, why? Because say I'm taking a beaker here or glass here. Now I'm taking some solids here. You will see the inter-atom-molecular attraction force between the solid molecules. Intermolecular attraction force between the solid molecules are highest here. The intermolecular attraction force between the solid molecules are highest because the intermolecular space between the solid molecules are very less. It is the least among other states of matter, that is liquid and volume, liquid and gas. Okay, so the first one we can say here, the intermolecular attraction force between solid molecules is highest among solid, liquid and gas. Okay, intermolecular attraction force between the solid molecules is highest among solid, liquid and gas, and it is vice versa with the intermolecular space. Intermolecular space is least between the solid molecules. Okay, intermolecular space is least among solid molecules. Okay, intermolecular space is least among the solid molecules. That's why the solid will have a particular shape and a particular size. In this table you get, in this structure you see, this will have a particular space or size. Okay, but same for liquid, the intermolecular attraction force between the molecules is least. It's less, not least. It's less than the solid. The intermolecular attraction force for liquid is less than solid. So if you want to write this one by a representation, then you can write this not very close to the molecules. Some distance will be there between the liquid molecules. Okay, so here as these liquid molecules are some apart from each other, so their space is greater from the solid molecules, so intermolecular attraction force is something less. Okay, so the for liquid molecules the space is something higher than the solid molecules. Okay, so just I am writing order for, I am not telling again for gaseous compounds. Okay, for order of intermolecular attraction force, order of intermolecular attraction force is solid greater than liquid greater than gas. This is for intermolecular attraction force. Okay, solid, it is highest for solid, then liquid, then gas. Okay, again it will be reversed for the intermolecular space. Intermolecular space order. order of intermolecular space of matter. It is reverse. Okay, it is highest for gas. Okay, it is highest for gas, then liquid, then solid. That is why the volume of gas is highest. Okay, volume of gas is highest, then liquid, then solid. Okay, so if you have any doubt regarding this video, you can ask me. Okay, over 4 or anything. Now today is up to this. Next day we will start giving another chapter. Thank you.